Let's go through integral data types in C programming. This is a language reference that is very useful in knowing where things are. We're going to keep coming back to this table quite a lot. Today, we're going to focus on just the integral part. So this includes in, long, short, float, double. There's a couple of other ones too. We will get into the imaginary stuff. It will be not be the focus of this class, but let's note from the very top, NC. These all coming from NC. NC stands for American National Standard Institute. So there's different various versions. So C8990, these stand for C version 1989 and C version 1990. But the latest one is C11, which is 2011. So along with every single one of these NC, there's more keywords being published or made available in those standards. These things, sometimes they are backward compatible, sometimes they're not. Like, let's say for very old compilers, if you have one, they may not recognize some of the C89 keywords like const, right? Enumerations, sign, right? This means positive, voids, volatile, and stuff like that. We're not going to get into every single one of them. Like I said, today's focus on this video is the integral data type. So we're going to jump straight to the table of data type right here. All right. So when we get into this, and you can see some of those, these types, they may not be integral. When I say integral, they are represented by digits or numbers. So char is one, sign char, right? Unsigned. The difference between sign and unsigned is sign is positive. Unsigned means, sign means positive, negative, and unsigned means positive. So the way to think about this is by default, these integral type, they're all signed, meaning they can go in the positive and negative realm, right? But if you just want an integral data type to go in the positive direction, then you have to specify unsigned. So in the format specifier, if you would have specified, this particular chart to be in the unsigned realm, so you have to attach this U character. So we'll talk about those when we get into the literals later on. Same with string as well. Let's look at the integer here. There's a whole bunch of them. So integer by default, this is signed. This means that this integer can go in the positive and negative direction. And just remember, every time you see it unsigned, this is only positive directions, right? Every time we have a long, so this is short for long end, right? Long end means it's longer. It's the size of long is bigger, right? Or equal to the size of an integer. So this long int is of 4 bytes. So 2 to the 32, right? Each byte has 8 bits. So 2 to the 32 means there's 32 bits total. So this entire range, it's actually, if you count the number of these, equals to 2 to the 32 in the number of permutations. Okay, so 0 included. Anyway, unsigned long. There's also unsigned long means that everything has to be in the positive direction, right? So instead of having this, now you can consolidate everything. There's actually this much, right? Like 2.1 billion-ish. They all go in the positive directions. So there's the equivalent number of them. So the number of characters, integers that you can have is 2 to the 32, right? In this regard as well. So there's also float, right? Float means that there could be decimal numbers, and float typically, they are much bigger than integer. Usually they are 4 bytes or sometimes 8 bytes too. Very platform dependent. So just think of anytime you have decimal like 0.1, 0.2, or even 3.14159, right? This pi, they could be using float as well. And if you scroll down a little further, you'll see float actually has another cousin called double, and this double is usually in the modern 64-bit computers. So float is about, double is about twice the size of float. So float usually have, and this may not true on all of the computers, but float usually has anywhere from 7 to 8 decimals. Okay, so you can have up to these many decimals, and double usually has 15 to 16. Okay, so this is just a general rule of thumb. They may not be the same. Just remember, double holds the same, twice the size of float. So if float is 4 bytes, then double will be 8 bytes, something to that effect. And long double is even bigger. And of course, a lot of these are platform dependent. So you don't need to memorialize it, but just remember every time you need precisions or even precision that goes into a scientific range when you do like astrophysics calculation and things like that, where precision is very, very important, then you want to use long double, right? So just remember in C, even in C++, there's long and short designations, and these are keywords that makes your storage capacity for integral type much, much bigger. So this is a short overview of this integral data type. So there's a couple of other slides we're gonna make use of to illustrate these more closely. This is a quick demo on some of the integral data types in C, as well as in C++. So in the interest of time, let me just copy and paste. This is available in your lecture. What we're going to do is going to use printf to print out the size of. Size of prints the number of bytes. So this is the integer. We're using a long signed integer designation here to print out the size of these things. As you know, short is short for short int. Long is short for long in, right? In the middle, we have int. So short is less than or equal to integer. Long is greater than or equal to integer, right? So if we print this out, so we can see we'll get it's 2 bytes, right? This one is 2 bytes. And so is this one, right? But integer in general is about 4 bytes, and then long has 8 bytes, so is long int. Okay. The same thing if you see other designations in the future. Let's say sometimes you will see long int. This makes it even bigger, makes the original long int much bigger. But it really depends on your not operating system, but your platform. Sometimes you can get only up to about 8, and in some of the areas you can get much higher. So this is a quick illustration of the size of integral types in C and C++.